Welcome to this lesson on classes and objects in C++, a cornerstone of object-oriented programming, or OOP for short. Today we'll dive into what classes and objects are, why they're essential, and how to use them in your programs effectively. By the end of this video, you'll be comfortable with the basic concepts and ready to start implementing OOP in C++. Let's start with the big picture. Object-oriented programming is a paradigm where we design our software around objects, which are entities that combine data and the functions that operate on that data. It's a way to model the real world in code, making it more modular, reusable, and easier to maintain. Important note, we have OOP only in C++, but not in C. C only have structures. In programming, both OOP and structures serve the purpose of organizing and grouping data, but they differ significantly in their capabilities and use cases. Structures in C++ are primarily used for grouping related data into a single entity, making it easier to manage multiple variables under one name. On the other hand, classes, which are at the core of object-oriented programming, go beyond just grouping data by combining both attributes data and methods functions into a single unit. This allows classes to represent real-world objects with both state and behavior. A key difference is that structures have their members public by default, while classes have private members by default, reflecting their different purposes. Structures are simpler and focus on data storage, while classes are more versatile, enabling encapsulation, inheritance, and polymorphism. For example, you might use a structure to represent a point with x and y coordinates, while a class could represent a circle, containing a point as its center and methods to calculate its properties. Thus, while they share similarities in grouping data, classes are a more powerful tool, supporting the core principles of OOP. Now let's break it down. In C++, a class is a blueprint or template for creating objects. It defines the data and behavior of the objects. Think of a class as the design of a car and an object as the actual car built from that design. The class is the blueprint, or the plan, and the object is an instance of the class. Let's see how this works in code. Here's the syntax for a class in C++. The keyword class is used to define a class. The public keyword makes the data and functions accessible from outside the class. Attributes, or data members. These are variables that hold the data for the object. Member functions. These are functions defined inside the class that operate on the data. Now that we've defined a class, let's create some objects from it and use them. In this example, we've created two objects, car1 and car2. Each object has its own copy of the attributes and can call the displayInfo function independently. Let's take a step back and ask, why use classes and objects? Here are some benefits. Encapsulation, bundling data and methods together. Reusability, once you write a class, you can use it to create multiple objects. Modularity, classes make it easy to organize your code into logical pieces. Abstraction, hiding unnecessary details and showing only the essential features. What is a constructor? A constructor is a special function used to initialize an object when it's created. Here's how to add a constructor to our car class. Let me explain you. The constructor has the same name as the class. It's automatically called when an object is created. Constructors make it easier to initialize attributes directly. Access modifiers control who can access the attributes and methods of a class. C++ has three main access modifiers. Public, accessible from anywhere. Private, accessible only within the class. Protected, accessible within the class and its derived classes. By default, members of a class are private. Here's an example. Here we've made the brand attribute private and provided public setBrand and getBrand methods to control access. This ensures data encapsulation and prevents unauthorized modification. When working with classes and objects, here are some common mistakes to avoid. Forgetting to initialize attributes leading to garbage values. Not using access modifiers properly, exposing sensitive data. Forgetting to delete dynamically allocated memory when using pointers within a class. Now it's your turn to practice. Create a student class with attributes like name, faculty, major, faculty number, and marks. Add a function to display the student's details. Add a constructor to initialize the attributes of the student class. Make the marks attribute private and use getter and setter functions to access it. That's all for today's lesson on classes and objects in C++. We covered what they are, why they're important, and how to use them effectively. Thank you for watching, and happy coding.